We are going to discover new ways of calculating the area of a triangle. There's a couple things that you already know that I want to remind you of, and then we'll look at this new way of finding the area of a triangle. When you have a triangle that this isn't necessarily a right angle, it's just a random triangle. When you know the length of the base and you know the height of a triangle, the perpendicular height is also what it's called, then the area of that triangle is 1/2 times base times height, right? You're actually imagining that it's a rectangle. You're calculating the area of this rectangle, base times height, and then you're taking half of that because half of the rectangle is cut off. Okay, that is one thing that you already know that we're going to use today. Then another thing you know but haven't worked with all that much is sine. This is angle A. Sine of angle A, I'm going to write it like that, is the proportion between two of the sides. In the case of sine, it's the opposite side, opposite of the angle, divided is that 2 p's? I have no idea. Divided by the hypotenuse. Some people remember this, SOHCAHTOA, and we're looking at this part. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But today we're only going to use sine, so only this proportion between opposite and hypotenuse. The opposite divided by the hypotenuse. So in the case of, let's say this side is 4 centimeters and this side is 5 centimeters, then the sine of this angle, sine of A, would equal 4 divided by 5, or as a decimal, 0.8, right? That is something we already knew. Now, let's look at this triangle. There is no right angles, it's just a fairly random triangle. In naming the angles and the sides, we usually stick to a certain pattern. If this is angle A, then we would call this side small a, the side opposite of the angle. So if this is angle B, big letter B, then this side is small letter b. That leaves this to be C, and this side opposite of angle C we would call side C. Okay. And as in this triangle, if we draw in this perpendicular line, perpendicular to this base, then we have the perpendicular height. That is going to come in useful with our triangle here. Watch me do this with my broken tools. This is now a right angle, right? And we will once again call that H. It's the perpendicular height of this triangle. Now, imagine we don't know this height. Imagine we only know this length, and the size of this angle. I'm going to show you how to calculate the area of this entire triangle with only using that information. Yes, so let's look at the sine of this angle. The sine of C. Sine of angle C. It would be opposite over hypotenuse, right? Opposite would be H over hypotenuse would be B in this triangle. So really, if we make H the subject of this equation, we have found a way to express H. If we multiply both sides by B, we'll get B times the sine of C equals H. And like we just reviewed, the area of a triangle is base times the perpendicular height. If we rewrite that, so the area equals the base, in this case, that's side A, 1/2, oopsie, times the perpendicular height, H. If we rewrite that now using this expression for H instead of H, because we don't know what H is, that would give us 1/2 of A times, instead of H we'll write B sine C. I could write all these little multiplication signs in between, or I could leave them out. So this is the formula to use when you want to find the area of a triangle where you know the size of one angle and the size of the two sides that meet in that angle. So it's like side, angle, side. If you know those three values, then you can find the area of the entire triangle using this formula. Pretty cool. Now if we had a nice example with a parallelogram and they asked us what is the area of this parallelogram, you would immediately notice that a parallelogram is made up of two equal triangles, right? If we find the area of this triangle, we just double it to give the area of the entire parallelogram. So to find the area of this triangle, we use our formula. Let me pull it up there. The area of the triangle, of the blue triangle, area of the blue triangle equals 1/2 AB sine of angle C, which equals 1/2, this is A, 8 times B, which is 4, times the sine of 120. Okay, I'm going to have to use my calculator to find sine of 120, unless I have that memorized.
Hoe heb jij dat gekund?
The sine of 120 is 0.87. When I plug that into my calculator, I can do this without a calculator. 1/2 of 8 is 4, times 4 is 16. Yeah. And when I plug that into my calculator, 16 times 0.87, ik had gezegd dat jij niet mocht komen praten, equals 13. Ja, doe maar, dat is goed. 0.856. So this, and we're talking centimeters, right? So centimeters squared, that is one of these triangles. And the parallelogram is made up of two of the same triangles. So 2 times 13.856 would be the entire shape, which is 27.7 centimeters squared. So even when they give you a funny shape like a parallelogram or a rhombus or any type of pentagon, you can cut that up into triangles and find the area of the separate triangles. And yep, that's it.